Right, so welcome to solving a linked list cycle issue 141. So in this question, we'll figure out how to identify whether a linked list creates a cycle, right? So one method we can do is using a pointer, a faster and a slower pointer. So imagine this, right? Um, 0 and then -4, and this -4 loops back to 2. So visually we know that it loops, but how do we identify from a code point of view? So we can have two pointer, one we call S, and perhaps a orange one we call S stands for slow, and then the orange one F stands for fast. Right, fast and slow. So using this pointer, we can create a while loop whereby so long as we don't hit a null, which is the end, a technical end of a linked list, um, the fast pointer would move twice compared to the slow pointer, right? And at one point, the fast pointer will loop back if there is a loop. If it doesn't hit null, if there is a loop, it will loop back and basically point to the same node as the slow pointer, right? So imagine the slow pointer goes node by node 1, 2, 3, 4, but the fast pointer jumps by 2 every time. And in that scenario, the fast pointer will eventually make a loop, uh, similar to how when you run in a track, if you have a fast athlete chasing after you, the athlete will eventually uh, lap you. And once they lap you, we know that you are your linked list, your track. Essentially, it loops around. So that is one way that we can solve this. Um, let's see. To code this, we will need to create a node. Okay, so maybe we can start with something like this. Create a node. Create slow node. Create a fast node. Okay. So how we can do that is this node slow equals to a, fast also equals to a. Okay. So now we have both the slow and the fast pointing to number 3. And then we can use in while the fast will reach the end first. Right, so fast is not equals to now. It will keep going. And we can do if fast no, we should actually move them forward first. This is the first step. Fast equals fast dot next dot next. Right. While slow is equals to slow dot next. Right. So if fast is not equals to slow, um, sorry, if fast is equals to slow, we will, if they point to the same thing essentially, we will return true. Otherwise, we will return false. Okay, so let's see. So if fast eventually becomes null, this while loop will break, and we will return false. This should provide me cannot read false. Okay, so null pointer exception. Sorry, I'm trying to figure out what's wrong here. Is one. This work? So okay, let me see. So what is my problem here? Hit position -1. The output is true. Is there any edge cases? No, it's a push. Internally appear as dealer syntax. Return true if there is a cycle. Oh, okay, so maybe let me try if QS is equals to -1, false. Otherwise, this work. No, the POS is not passed out. Okay. Is there a way for us to check if it's single? What if we do this? So long as there is the next item is not now, we will move slow first, and then if so, essentially, what's going on here is yeah, let's see. Fast. So this will go here first. Then you'll check. The fast and slow will be checked. And then if fast does not equals to slow, fast will jump 2 times. Here. Fast will go here. Right. And then let's say that's 4, right? Slow will go. Next slow goes here. And then we'll check if fast is equal to slow is correct. Then we consider this a loop. I feel like this could cause an error. Let's see. I think I will have some false. Cannot read build dot next. Oh shit. This is still some stuff I'm missing. Do we do integer POS like this? I don't think this is how it works. Right? It cannot be applied. Which is quite interesting. So if fast does exist, fast is not now, we'll move the slope forward first, and then we will check if fast is equals to slow. If it is, we return true, otherwise fast will move double forward. If there is a loop, but you see the problem here, right? On the next move, when slow moves forward, and then we do a check on fast and slow, fast will be slow no matter what. So in this case, I should get my some of it correct, 2 correct, right? Then they will run cannot read next. What if I do if fast.next is equals to now let's return false, something like this. Will this give me some correct? Okay, I'm making some headway. So the here is -21. Let me see. There is no loop backwards. I don't think I use sort in this scenario. Um, we will try this for 5 more minutes. I didn't put a stopwatch. And if I cannot, we'll call it. Create a slow node to track the hit. Create a fast node to track the hit. Fast, this is, there's some test cases that are not premium debug. Expected false, that means there is no loop. Hmm. The input is POS1. First stop POS. But the problem here is POS is not passed as a parameter. Don't choose this like otherwise. I give up. So while fast is not now, I also need to check that fast next is not now. Then my fast can move 2 steps forward. Ah, so that was what I was missing. I was overthinking too much. So granted, fast is not now, and then fast next, this is not now, and then I'll move this forward like this. Okay. So I think this should work as well, no? Yes. And this is essentially fast.next is not equals to now. This should give me the same output. And yeah, the time complexity here should be O to the power of n, looping the number of time it moves. Yeah, in a worst case scenario, it will go through the whole node once for a match. So that is how I would do a linked list cycle. It is not the best way to do it. I mean, it is not how I would like to do it. Ideally, I would not like to refer to answer. But it's my first time doing LeetCode, so let's see how far I can improve from here on.